Hadoop is an open source program supported by the Apache Foundation that implements MapReduce in potentially thousands of computers. Hadoop could drive the process of finding and counting the Google search item, but Google uses its own proprietary version of MapReduce to do so. Hadoop began as a part of Cassandra, but the Apache Foundation split it off to become its own product. Hadoop is written in Java and originally ran on a Linux. At this moment, Microsoft is reported to be implementing its own Windows Server as well. Some companies implement Hadoop on server farm they manage themselves, and others run Hadoop on the cloud. Amazon.com supports Hadoop as part of its EC3 cloud offering. EC3 stands for Elastic Computing Cloud. Hadoop includes a query language entitled Pig. At present, deep technical skills are needed to run and use Hadoop. Big data analysis can involve both reporting and data mining techniques. The chief difference is that big data has volume, velocity, and variation characteristics far exceeds those traditional reporting and data mining. Nothing is more frustrating for a manager to contemplate that the situation in which one employee struggles with a problem that another employee knows how to solve easily, or to learn of a computer who returned a large order because the customer could not perform a basic operation with the product that many employees or other customers can readily perform. Even worse, someone in the customer organization may know how to use the product, but the people who bought it did not know that. Knowledge management, or KM, is the process of creating value from intellectual capital and sharing its knowledge with employees, manager, customer, and others who need the capital. KM benefits organization in two fundamental ways. One, improve process quality, and two, increase team strength. Process quality is measured by effectiveness and efficiency, and KM can improve both. KM enables employees to share knowledge with each other and customer and other partners. By doing so, it enables the employees in the organization to better achieve the organization strategy. At the same time, sharing knowledge with each other employees to solve problems more quickly and to otherwise accomplish work with less time and other resources with improving process efficiency. By sharing knowledge, team members learn from one another, avoid making repetitive mistakes, and grow as business professionals. The goal of KM is to enable employees to be able to use knowledge processes collectively by people in organization. By doing so, both process and quality and capability improve. The earliest KM system is called expert system. They attempt to directly capture employee expertise. They existed long before social media and in fact were in use long before the internet. Expert systems are rule-based systems that encode human knowledge in the form of if and then rules. Such rules are statements that specify if a particular condition exists, then to take some action. Figure 9.24 shows an example of a few rules that could be part of medical expert system for diagnosing heart disease. The program that process a set of rules are called expert system cells. Typically, the cell processes rule until no value change. At that point, the value of all the variables are reported as result. Many expert systems were created in the late 1980s and early 1990s, but only a few have enjoyed success. They suffer from three major disadvantages. First, they are difficult and expensive to develop. They require many labor hours from both expert in the domain under study and designer of expert system. Second, expert systems are difficult to maintain because of the nature of rule-based system. The introduction to a new rule in the middle of hundreds of other can have unexpected consequences. A small change can cause very different outcomes. Unfortunately, such side effects cannot be predicted or eliminated. They are the nature of complex rule-based systems. Third, expert systems were unable to live up to the high expectations set by their name. Initially, proponents of expert systems hope to be able to duplicate the performance of highly trained experts, like doctors. It turned out that no expert system has the same diagnostic ability as knowledgeable, skilled, and experienced doctor. Even when the expert systems were developed that came close to an ability, changes in medical technology required constant changing of the expert system, and the problem caused by unexpected consequences made such changes very expensive. Another form of knowledge management concerns knowledge that is encoded in document. Content Management System, or CMS, are information systems that support the management and delivery of documents, including report, web pages, and other expression of employee knowledge. Typical users of content management system are companies that sell complicated products and want to share knowledge of those products with employees and customers. For example, someone at Toyota knows how to change the timing belt of the four-cylinder 2013 Toyota Camry. Toyota wants to share that knowledge with car owner, mechanic, and Toyota employees. The challenges are, first, most content management are huge. Some have thousands of individual document, pages, and graphics. Second, content management system contain a dynamic. For example, most web pages content change every day. Third, documents do not exist in isolation from each other. Documents refer to one another, and when one changes, others must change as well. To manage this connection, content management system must maintain linkage among documents so that content dependencies are known and can be used to maintain document consistency. Fourth, document content are perishable. Documents become obsolete and need to be altered, removed, or replaced. For example, consider when a new product is announced. Figure 9.5 shows the main page for Microsoft.com less than 2 hours after its announcement of Surface. We can only wonder how many other pages on Microsoft.com needed to be changed within those 2 hours. Fifth, content is provided in many languages. For example, 3M has tens of thousands of products, some of which are harmful when used improperly. Figure 9.26 shows that 3M must publish product safety data for all such products in all the languages listed on that web page. Every document, in whatever language it was authored, must be translated to all languages before it can be published on 3M site. If one of them changes, all of the translated version must change as well. In the past, organizations developed their own in-house content management application. However, because of the expanse of custom application, many organizations today use off-the-shelf software. Horizontal market products like Microsoft SharePoint provide generalized facilities to manage documents and other content types. Some organizations choose vertical market off-the-shelf application. An accounting firm, for example, may license a vertical market application to manage document flow for the processing of tax returns or the management audit document. Such off-the-shelf products have considerably more functionality than most in-house systems, and they are far less expensive to maintain. However, some organizations just rely on internet search engine to manage their content. This is content management of the cheap. Just put document on a public server and let Google or Bing do the rest. However, documents that reside behind corporate firewall are not publicly accessible and will not be reachable by Google or other search engine. Organizations must index their own proprietary document and provide their own search capability for them. In recent years, social media has changed the orientation of knowledge management. In the past, the focus was on structured systems such as expert system and content management system. This knowledge management technique relied on planned and pre-structured content management and delivery method. However, social media foster emergence. In knowledge management context, employees and others express their knowledge in a variety of modes and media, and the mechanism for managing and delivering that knowledge emerges from usage. Hypersocial knowledge management is the application of social media and related applications for the management and delivery of organizational knowledge resources. Progressive organization encourages their employees to tweet, post on Facebook or other social media site, write blog, and post video on YouTube and any other site. Hyperorganization theory provides a framework for understanding this new direction in knowledge management. In this frame, the focus moves from the knowledge and content per se for fostering of authentic relationship among the creator and the user of that knowledge. Figure 9.27 lists common hypersocial knowledge management alternative media. Whether its medium is used for public, private, or either, and the best group type. A new media is called Rich Directory, which is an employee directory that includes not only the standard name, email, phone, and address, but also organizational structure and expertise. With a rich directory, it is possible to determine where is in the organization someone works, who is the first common manager between two people, and what past project and expertise an individual has. For international organizations, such directory also include languages spoken. Microsoft Product Active Directory is the most popular rich directory. Rich directory is particularly useful in large organizations where people with particular expertise are unknown. For example, who at 3M knows which 3M product is the best to use to glue thick wood to fiberglass? Probably doesn't. But who are they? And who is the closest to a factory in Brazil? If no one is near Brazil, is there anyone who speaks Portuguese? Two human factors inhibit knowledge sharing in hypersocial organizations. First, employees can be reluctant to exhibit their ignorance. Out of fear of appearing incompetent, employees may not submit entries to blog or discussion group. Such reluctance can reduce the attitude and posture of manager. One strategy for employees in this situation is to provide media that can only be accessed by a smaller group or people who have an interest in a specific problem. Members of that smaller group can then discuss the issues in less inhibiting forum. The other inhibiting human factor is employee competition. A hyper-social knowledge management application may be ill-suited to a competitive group, or the company may be able to restructure, reward, and incentive to foster sharing of ideas among employees. For example, giving bonus to a group that developed the best idea. For business intelligence to be actionable, it must be published to the right user at the right time. Figure 9.28 lists 4 server alternatives for business intelligence publishing. Static reports are business intelligence documents that are fixed at the time of creation and do not change. For example, a printed sales analysis. Most static reports are published as PDF documents. Dynamic reports are business intelligence documents that are updated at the time they are requested. For example, a sales report that is current at the time the user accesses it on a web server is a dynamic report. In almost all cases, publishing a dynamic report requires that business intelligence application to access a database or other sources at the time the report is delivered to the user. Pull option for each of the server in figure 9.28 are the same. The user goes to the site, click a link, or open an email and obtain the report. Push option vary by server type. For email or collaboration tool, push is manual. Someone creates an email with the report as an attachment or URL to the collaborative tool and send it to the user known to be interested in that report. For web server and SharePoint, user can create alert and RSS or really simple syndication feed to have the server push content to them when the content is created or changed. With the expiration of a given amount of time or that particular interval. SharePoint workflow can also push content. A business intelligence server extends alert to support user subscription, which are user requests for particular business intelligence result on a particular schedule or in response to a particular event. For example, a user can subscribe to a daily sales report requesting that it be delivered each morning, or the user might request that RFM analysis be delivered whenever new result is posted on the server. A business intelligence server is a web server application that is purpose-built for publishing a business intelligence. The Microsoft SQL Server Report Manager, as a part of Microsoft SQL Server reporting services, is the most popular of such products today, but there are other products as well. Business Intelligence Server provide two functions, management and delivery. The management function maintains metadata about the authorized allocation of business intelligence result to user. The business intelligence server tracks what results are available, what users are authorized to view those results, and the schedule upon which the results are provided to the authorized user. Business intelligence server use metadata to determine what result to send to which user and on which schedule. Today, the expectation is that business intelligence result can be delivered to any device, which any means computers, smartphone, iPad, and other tablets, applications such as Microsoft Office and SOA, or Service-Oriented Architecture web services. Not every business intelligence a success, but even simple ones like RFM and OLAP often are successful. A complicated and expensive data mining application can generate tremendous return if they are applied to appropriate problems and are well designed and implemented. In 2024, data storage and CPU are free. The world is generating and storing exponentially more information about customers, and that data mining techniques are only going to get better. It is likely that by 2024, some companies know more about your purchasing awareness than you, your mother, or your analyst. What happens when business intelligence application becomes sophisticated enough to replace the business intelligence analyst? What happens when the unsupervised data mining application has features and functions to find its own data set and to evaluate those data sets and based on the result of prior business intelligence analysis, and then decide which business intelligence analysis to perform next? Machines work faster than humans, and they work 24/7. At some point, will machine know so much about us that we are incapable of understanding the result? What happens if, because of the complexity, such business intelligence machine can only communicate with other business intelligence machine? What happens when machine can direct their own data mining activities? There will be an accelerating positive feedback loop among business intelligence machine. Then, what will they know about us? The day when unsupervised data mining truly is unsupervised, machine will process and create information for themselves. This is the end of chapter 9. Thanks.